I'm here in the studio just working on a machine of my own design, a heated wax pump, and that is because of scale. I've started scaling up the process for this enormous public sculpture piece I'm working on, and that means at its longest point the sculpture is going to be 2.5 meters, which means I need some new equipment in the studio, and I don't think it exists, so I started building it over the last few months, and I'm at probably 99% complete. The project is so pregnant, it is so ready to go. I keep thinking it's this week, and a little thing will pop up, but I think it's this week. So at the moment I'm just working on the circuitry for the design. I'll go over the actual machine in a little bit. And so effectively the problem that I currently have is my current process rather is that I print moulds around, I don't know, yay big. I fill them with wax, I lift them up and slash cast them, pour the wax out. I'm then left with a shell of wax around the inside at hopefully 5 to 7 millimeters. In most instances over 20 or 30 centimeters tall. Bronzes are hollow. And this is primarily, I guess, because of weight. If we were moving solid bronzes around, it would be insane. But also, actually, when you're driving so much thermal energy into the mould material, the plaster, the sand, the clay, whatever ingredients are kind of mixed into your what you're called investment or your ceramic shell, depending on your casting method, your mould needs to be able to withstand that effectively. And if you're filling it solid, you're obviously pushing more thermal energy into there, which is more likely to cause cracking and lost metal, lost casting. The idea is to keep the mould, the wax, between 5 to 7 millimeters thick. And in this instance, I can pour it out, slash cast it, and arrive at. The lighting may not be great, maybe it's good enough. It's quite good with the laptop behind it. I will arrive at something like this, a sort of figurative proposition. Once all the porcelain's removed from the outside, which is 3D printed with my machine. Again, I'm sure I've got that linked into another video somewhere. But yes, so this will be 3D printed with porcelain and then removed, and you get this sort of proposition for a figure that sometimes looks like he's stood on his two delicate legs. He's almost got this large form around his waist, like a billowing dress or something. He's got one hanging arm and the other one coming up to kind of hold his forehead, whether he's exhausted or saluting. I'm not necessarily sure. And it kind of pushes the figure into this area that's between figurative and these naturalistic stone, kind of sedimentary, coral-like forms. And when trying to do that at scale, with the moulds being porcelain, they get very heavy very quickly. The one I've currently printed and lifted is probably around 100 kilos or so. So I don't have the same options to lift and kind of twist it around. And so the idea is here, I've built this machine, the heated wax pump, and that will have a hot line to make sure there's no blockages. I'll have a hot line from, at one end there'll be 2 wax melter machines that I have here. They're 70 litres each. I've got 140 litres of molten wax. That will be moved through the pump powered by a motor, which will be pumping the wax, hopefully at 1 litre per second, to quickly fill the moulds with wax. That will then be left to set for a moment around the outside when it comes into contact with the cold clay, and then in theory the motor reverses direction and pumps back into the wax melter. So the key is here that there's enough heat along the line to maintain fluidity and make sure there's no blockages. So that's the first thing that could go wrong. The second thing is that we could have some cracks in the mould, and ultimately my studio would be covered in like that much wax on the floor, which would be incredible, but it would be such an incredibly expensive mistake. I'd be so sad. So hopefully that doesn't happen. And here I'm just working on the circuitry. I've got my plan kind of all on the laptop here. I imagine that's blown out as hell, but my plan's all on here. So that's just because I've planned the size and what kind of size junction boxes and things that I need. So I've just been doing that in Illustrator. Maybe I'll pinch that in here and you can have a look over how I've been sort of planning the circuitry. It's been quite fun. I haven't done that before. I also find it quite weird how our bins are the same colour as the colour of our like wiring. Like, why do we need brown, blue and like green wires in our plugs and our bins to be the same colour? That's something I was thinking, and I keep seeing it around, and I find it quite confusing. So all I've been doing just is the motor, which is here, just coupled up to the pump. So the pump's kind of encased in all of this, the heat trace and the glass fibre tape. But now the motor, I've just secured that in place. So now, because the problem was before, obviously that was kind of spinning and moving around as it was rotating. Fuck! The issue was, I'd previously had it sitting on some 18mm board, but the kind of axes were a little bit out between the axle of the pump and the axle of the motor was slightly out, so I had to change that by, I think it was 6mm, or it was literally, no, it wasn't 6, the difference is 6, then I had to shimmy it by 5, so I think it was like a 2mm difference to get it to line up perfectly, but it does anyway, which is the main thing. So yeah, now that's connected. I need to obviously wire everything back up, but I believe my last step at this point, where the heat trace is around the pump here, I tried to bond it in like a previous video, this kind of JB Weld, but as you can see it hasn't worked, so I need to just get that to make contact with the face of the pump, just so there's a little bit of heat being driven into that. So I'm just going to be doing that now. So I'm actually just drilling in the last part now, and it's funny, like every part up to now, I guess the last few parts, they kind of require a bit of like pokery. It's almost like as the project goes further on, because there's little things that you've tried to plan for but you kind of haven't, these things fall through, and it's just a little bit so I've had to fashion this little it's just a wooden jig to hold this heat trace as kind of close as I can to the faceplate of the pump, just to make sure there's no cold spots and hopefully no blockages. So I've just clamped that into place just to get it as tight as I can. I'm now going to drill it, but the good news is actually this is the last thing that I need to actually kind of fit to the pump. Everything else is actually just wiring it back up. Just wiring it back up and connecting things. So this is actually the last part of the pump. I think the plan at the moment is just to this little weird thing that I've screwed together with a few bits of wood just here. I'm just going to be screwing that down into the plate, just so that it's actually held in place. So let's see how. This is in no way a long-term solution. I don't like the idea of having the wood in contact with the heat trace, because this climbs to a lot higher than the 60 or 70 degrees to melt the wax. So the plan originally for the jig was to put a bit of a faceplate in like this, but actually I think let's see anyway if this clamps even. That's pretty good actually. Yep, that's good, we've got contact. As I say, I'm just going to have a little bit of a tidy of the pump. Just I've got a few tools and things out still, a few screws and whatever. I'm just going to have a tidy up. Then I'm just going to reconnect some of the components and rewire it. And that mould's a little bit wet to do today, but I might try and squeeze it in a little bit. If not, I'll be pumping tomorrow. But yeah, I'll be checking in a moment. So the pumping machine is in its final, final for prototyping purposes form, where I'll be printing the test mould, casting the test mould, which is here. So that's just drying before I cut a hole into it and then insert the pump. But what I'm going to be showing you at the moment, so you can just see the motor's all fitted on, everything's kind of wired into place, and I'm just about to switch it on. I don't think of the best angle here. And so when I switch the power on here, everything will power on, as you can see. And so what's happening here, I'd had it on earlier when I was just doing some wiring, check some stuff. That's why it's preheated. So you can see here, the ideal temperature that I've set it at is 80 for this long line, which will be inserted into the mould here. That's on its way to 80. You can just see that here. This is brand new. I've only just wired the heating element, this red trace, onto the pump, which is in here, attached with a spider jaw coupling to the motor. I've just got the LED, which indicates there's power going through the circuit, and then what's called a Hall sensor here, and that's detecting a magnet, which you can't quite see, it's on the bottom edge here, and when that runs past the sensor, this LED will light up, which indicates it's detected the magnet, and that will then indicate the revolutions per minute on the screen to the top right here. I had a few, I think I showed earlier, but this was a bit of a faff. Again, all kind of prototyped. So that's what this is for, and then the third one is for the line, which is going to connect to the wax melters. And so this here, similar circuit, or identical rather, in the sense of it just being for one. That's just switching on now, and then that'll be heating this up to 80, which makes sure there's no blockages happening in the elbow here, the kind of T-junction, and then that'll go on to the pumping device that I've just gone through. And so just to run you a little bit through the kind of makings of this, so these are Omron PID controllers, and these are basically detecting a temperature on part of the pump through the thermostats, which are on here. These are taped round the pipes here, so those are the kind of target zones that I want to be hot. I can, if I want, individually switch these on and off. So I was having a bit of faff doing this one handed and not getting electrocuted. But as you can see here, actually, let's do it like this. So this light here is switching. This light here is switching on to indicate power going through this line. If I want to isolate that for any reason, switch it off, I just switch off the circuit, that LED will go off, this will go off, and the heat on that line will go off. So I control each one individually like that. Everything's also obviously on breakers. These are solid state relays, so these take a 12 volt, I think it's 12, maybe 24 volt signal that gets put out by the Omron to indicate. So when it says out flashing here, that's to indicate there's a signal going to the solid state relay. That's then going to power the much higher voltage heat trace, which runs through here. And so that's at, I think, 220, 230 volts. But the important thing is with solid states you can run much higher kind of voltage equipment. Anyway, the last thing which I've been most excited about is the motor controls, which are, that's the tachometer, which will tell me how many revolutions per minute. This is for the motor direction, as in forwards and backwards, and that will be responsible for either sending wax in this direction to the mould, or responsible for sending it back this way and draining the mould and filling up the melters, which are currently full and kind of ready to go. So I just want to kind of check that motor is going to be working. I can't run it for too long at the moment with no wax or anything in the line. I'm pretty sure it's quite bad for the pump to just be doing that. So this unit at the bottom is for speed, which is what's going to be happening now. So first of all, I'll indicate the direction. Let's turn this all the way down. First of all, I'll be indicating the direction, which in this case forward, which I'm pretty sure is this direction. Maybe I've reversed it when I wired it, but I'm pretty sure that should be feeding wax in. And as I turn the dial, you'll see this spin, which indicates the pump inside is turning. So the issues I was having previously was that the motor was spinning freely here, but that's all braced down, so that's eliminated. And then lastly, we can just see here the revolutions per minute. So this can go up to 2,800, which should indicate we're doing 50-60 litres a minute. And so I can turn that off, like so, and then I can reverse the direction. And yes, that will be now, well, tomorrow rather, I'm going to be focusing on cutting the hole here and feeding that up. And then we'll be pumping wax in through here, and this should fill up. So yes, that is the system that I've been building over the last few months. And if all goes well, I'll be housing this obviously into a proper kind of junction box. It's got its own control panel. But for the moment, prototype kind of working version 1 complete, I think. So yeah, I'll be checking in tomorrow and making a bit of a recording on the actual casting of the test mould. Following that, I'll obviously be moving on to the much bigger, more risky one. But yeah, so I'll be checking in tomorrow with some mess from the wax machine and the pump, I'm hoping. I just hope that tomorrow I start to see some liquid wax being pumped. That just has to happen. The studio's been so pregnant with it for so long that we've been so close that just need to pull the trigger tomorrow and actually, yeah. But the important thing is today, those last few little bits have been fitted onto the machine. It's now in its kind of, as I say, its final state. So yeah, I'll be checking in tomorrow with some pumping and some wax action. So yeah, till then.